All right, thank you very much for coming. Before we begin, let me start by introducing myself. My name is Nitesh Danjani, and I have the URL to my blog up there if you are interested in keeping up with what I have to say. I currently work for a corporation in the United States. My job responsibility there is to head their application security practice, and my team also performs network and application level assessments globally. Before that, I was a manager with Ernst & Young. My team performed attack and penetration reviews for our clients. And before that, I was a consultant with Foundstone. Before we get started, let me ask and answer the question, why is application security important? I rarely believe anything that comes out of Gartner on face value, but I believe them when they say that most of the attacks today happen at the application layer. You don't have to believe the number is 75%, whatever the number is. I think most of us in this room will believe that number is pretty significant. The reasoning for that perhaps is you take an enterprise level web application or a web service that is exposed to the internet. And let's assume that this application is large in size. You would have anywhere between 500,000 lines of code to 1 million lines of code. So the opportunity in this, in such a large amount of code to do something wrong is pretty big. And if there is a defect in it, even in one line of your code, somebody that has, just has a web browser can have access to your database just from the web browser. And network level controls do nothing to stop application level attacks in most cases. In some cases, they even facilitate the attacks. So with that in mind, and also knowing that the title of my talk is called Breaking and Securing Applications, given the amount of time I have, I don't want to really turn this talk into a methodology on how to hack applications. You'll probably find a lot of books about that. You don't need me to tell you how to do that. But instead what I want to do is concentrate on two high-risk attack vectors, cross-site scripting and cross-site request forgery, to illustrate certain points, to illustrate certain thoughts I've had with the application security industry today and how we can make things better. I'll be the first person to tell you that if we want to assess an application, you really need to do a lot more than just XSS or XSRF. But the reason I'm picking on these two attack vectors is they're common, and they're good guinea pigs to illustrate other points I want to make. And those points are that we need to do a better job of understanding root causes of these high-impact attack vectors. Cross-site scripting is a favorite of mine because I think even in the security industry, people misunderstand what cross-site scripting is. You'll find books and white papers that will tell you that cross-site scripting is an input validation problem. But if you look at the root cause of cross-site scripting, it's output validation, not input validation. We need to do a better job of demonstrating impact of these high-risk attack vectors. I want to go through a case study where I found a XSRF issue in one of Yahoo mobile application, and there is reason why this is a lot more interesting to me, and we'll talk about that. We'll talk about the complexities of assessing for XSS and XSRF. And of course, again, I tell you, I'm picking on these two attack vectors, but when I start talking about complexities and automated tools, I hope what you will take away from this talk is not just XSS or XSRF, but in general that there are some flavors of attack vectors that automated tools can never find. But at the same time, let's talk about what we can do to make these tools better. We'll talk about how, when you talk about XSRF, it's always fair to mention that XSRF can be abused by an entity that's sitting on the internet to make your web browser, assuming you're on an intranet, perform transactions within the intranet context. And so we'll look at an example of that. And now that we're talking about XSRF and how XSRF is really when a malicious user abuses your browser to make it perform transactions, let's talk about as an application owner, assuming you are an application owner for a business. If there's a vulnerability found in the web browser or components within the web browser, what does that mean to you? Throughout the talk, when I mention assessment tools, I want you to think of two different flavors of application assessment tools. One is the black box assessment tools. So you have vendors like AppScan and Spy that want to sell you their black box assessment tools, where you give it a URL, perhaps a login and a password to an account. It will spider the application, try to find vulnerabilities. But at the same time, I'm also talking about static code analyzers. Companies like Fortify and Ounce Labs want to sell you these products. The reason these products are important is not only because they cost hundreds of thousands of dollars, so you have certain expectations from them, but this is an important topic to me because people in the enterprise rely upon these products for their security needs. I'm a big advocate in the fact that even though we have these great tools, that a human mind should always be involved in an assessment. In fact, I think an automated assessment tool or a code analyzer is only just the first pass of an assessment. So really, like the statement, a fool with the tool is still a fool, right? You could put a dumb person in front of a really good tool, you'll get garbage out. But at the same time, if you can take an assessment tool and make it better, why not? It saves money and it saves resources. And yet again, we'll talk about the complexities of assessing for XSS and XSRF, but these are just two examples. Before I get to the core of the presentation, I want to mention an argument that I sometimes find people in the industry making, and the argument goes something like this. There are people who think that there are types of vulnerabilities that can be parsed for, which is in one bucket, and then you have other types of vulnerabilities that can never be parsed for, that appear to be design-only issues. I think that's a dangerous argument because it stifles innovation. There are at times when you take a look at something and say, well, this looks like a design-only issue or a logic issue. A code analyzer could never find this because of Turing's halting problem or anything like that. Things that assume that appear to be design issues with enough frequency and probability, you can always derive patterns out of them and actually end up parsing them. So a more healthier argument is to say that there are some issues that we know are in the design-only bucket. What can we do to find patterns from them and put them into the bucket that can't be assessed for? So I pick on cross-site scripting and XSRF to illustrate my points because they are extremely high impact and they're popular. Within the web security industry, people will really admit that they're tired of hearing about this cross-site scripting thing. Well, that may be true, but the fact of the matter is that it is extremely common and we must do something about it. Lack of understanding is a big problem. You have a lot of people who think they understand cross-site scripting, but mistake it with input validation. And of course, assessment tools have not caught up. Okay. To show you how popular XSS is, here's a semantics site that is vulnerable to cross-site scripting. Here is Microsoft sites that's vulnerable to cross-site scripting. Do I think they fixed this? Fox News' site vulnerable to cross-site scripting. I think this is they're still vulnerable. In these situations, what I did is I just popped up an alert box to give you technical proof that there's cross-site scripting. That doesn't do much good if you're sitting with a business owner, an executive who's not technical, doesn't need to be technical, and trying to convince him or her why this is a big impact. There's a lot more you can do with XSS than just pop up alert boxes, as in Daniel's presentation. You can steal cookies, lock keystrokes, port scan the intranet, steal browser history, and so on. In order to illustrate the impact of XSS, what I like to do is use a tool called Beef, which is really an XSS proxy. It's extremely similar to Daniel's presentation. In fact, this was the first time I've seen Daniel's talk, so perhaps next time I'll talk about his tool instead of Beef. Beef is extremely similar. In this case, I'm setting up Beef. It's a web application XSS proxy, and saying that when somebody hooks into Beef, show them the word defaced. So what Beef is really doing for me is when I want to demonstrate the impact of XSS, instead of writing my own JavaScript malware, I let Beef do all the hard work. So in this case, I'm saying, show the word defaced. And what I'm going to do is go back to my Fox News example, the URL, and instead of actually injecting my own JavaScript, I'll just inject the URL location to where beef is installed. Right? And so when the victim clicks on this link, he will see defaced as output by beef. Now you as an attacker, from the view that you're seeing, will see the victim's IP address pop up as a zombie, and you can get all sorts of wonderful information about the victim, such as the browser information, the operating system, the screen resolution, any applicable cookies, the HTML the user is seeing, as well as, in this case, the keystrokes the user has typed into his browser session and browser history. So if you haven't checked out beef, I would highly recommend it. So let's going back to the problem of cross-site scripting being an output validation problem. In order to convince you of that, if you're not already convinced, let's take a look at the most simplest CGI script you could ever write. Hello world.cgi takes in a parameter called name. In this case, we have Bob, and it just outputs back Bob, so hello Bob, right? Now let's assume for the first scenario that this CGI script is vulnerable to cross-site scripting. So in order to exploit that, instead of Bob, I would inject HTML code that would have JavaScript in it that would send back my cookie to an attacker. And that's what this would look like. You have the HTML code in for the name parameter that's output back without being escaped, and therefore you have cross-site scripting, right? Fairly simple. The browser looks at this result. The browser doesn't know what's going on. It thinks it's the actual application that's asking it to render this HTML and execute the JavaScript code. Now let's assume a scenario where the CGI script is not vulnerable to cross-site scripting, right? So for the same input, now you have the HTML entities escaped. So if insert the lesser than sign, the browser sees ampersand LT semicolon. The browser looks at this output and says, instead of actually executing this HTML, this is not HTML, this is text I need to be displaying to the person viewing the website. So in other words, it is during output that when you escape, or if you don't escape, is when cross-site scripting is caused. Therefore, that's my conclusion that cross-site scripting is really an output validation problem at the root cause, not an input validation problem. Therefore, preventing XSS, HTML escape as much as you can. Unfortunately, even though XSS is really an output validation problem, depending on where you're outputting a dynamic string, you may unfortunately have to do something inelegant as input validation. And the XSSDB website is a pretty good URL you can go to, which has cross-site scripting vectors based on HTML tags, so you can figure out if you really need to be doing input validation in addition to output validation. And of course, a whitelist approach is always the best thing. Persistent XSS is when things start to get complicated and interesting at the same time. The example we looked at before was non-persistent XSS, where you input something and the application echoes it back immediately. Now consider the case where you input a parameter in as a get or post, and the application accepts it and stores it at some data store. It could actually be a database, or it could be a server-side variable. And let's assume a scenario where the application, say you submit a form and you put in some HTML code in there, does not echo it back until some later form shows up, or a different section of the website. That kind of persistent XSS is extremely difficult to find automatically. To think about why, let's assume what would you do if you had to write a black box assessment scanner to find cross-site scripting. You would have a simple algorithm like this, and this is what most of the off-the-shelf application scanners do. You point it to an application, they try to crawl the application, find out what different URLs there are, get a hold of the get and post parameters, and try to fuzz the application with different HTML entities. Then the fuzzer will look back at the result that comes back and says, well, I put in an HTML character here did the application escape it or not? Well, if the application did not escape it, I will report it as cross-site scripting. If the application did escape it, let me try some more combinations and permutations before I give up. Works beautifully for non-persistent XSS, but for persistent XSS, no tools in the market are able to scan for this. So you scan, you run an automated scanner, and you have a Form A that takes an input and Form D that actually displays it. An automated scanner today will not find that. One of my recommendations for that is, actually it is a pretty easy thing to do, is when you write your fuzzer, to remember what things you fuzzed for, and then later if you see it again, you mark it as cross-site scripting. So let's see what happens when it comes to static code analysis. You run a code like this against a static code analyzer, and it'll tell you with 100% assurance that I found cross-site scripting, right? Because this is non-persistent. We have a parameter that's been put into a string and then echoed back in HTML. Fairly simple. Now look at the persistent example, right? This is where code analyzers go for a toss. You have something that comes out of a database and then echoed back into HTML. Well, code analyzers don't parse SQL, so they have no idea if cross-site scripting is really happening. For all they know, you could be pulling things out of the database. It could be numbers, right? And consider the case where application A takes in data and application B pulls it from a database and displays it. A code analyzer is never going to catch that flow. It is clear that in the two application scenario, the application that's doing the output is the one that's vulnerable. But from an assessment perspective, where you're trying to find risk and trying to figure out if XSS is really taking place, a code analyzer is not going to do a good job of finding persistent cross-site scripting, which I think is a pretty big deal. The reason I bring it up is, if you look at the statistics, cross-site scripting is the #1 attack vector across the board for all applications. And yet, code analyzers are not able to do a good job for persistent XSS. And when you open up the marketing brochures for all these tools, nobody will tell you that. So in the persistent case, you have a code analyzer reporting a suspicion that there might be cross-site scripting. Now you take this scenario and apply it into an enterprise level application with 1 million lines of code, you'll have 5,000 suspicious things that the code analyzer will report to you. Now, the usefulness of that has just greatly diminished, because now you have 5,000 different things to look at. And I think the reason, one of my big beasts for automated tools these days is the requirement, I think perhaps from the marketing department or from the sales department, that these tools be so easy to use that really actually makes them less useful. If I were to write a code analyzer, the simplest thing is, before you run static code analysis on a piece of software or a piece of source code, make the analyst tell you where is the anti-XSS function, right? It's actually extremely simple, and we'll see in the case of XSRF that the only way to detect XSRF automatically is to make the analyst give you more input before starting the scan. I think we mentioned this. So cross-site request forgery, perhaps most people in this room already know it, but just in case, is really where you force a user's browser to perform transactions on another established application sessions without the user's knowledge. So take, for example, a malicious site at shady.example.com, and let's just say you browse to that website. And the HTML that is sent to your browser contains this, this piece of code, where you have image source equals somebank.com/transaction.cgi, amount parameter, a really big number, and to account, the hacker's account number. Let's also assume that you have another browser tab open and you're logged into somebank.com. Your browser thinks it needs to load an image. It connects to somebank.com, realizes it already has a session established, sends the appropriate session cookie, and then performs the get transaction, right? Somebank.com, the application there, looks at the transaction and says, it has no way of understanding what's going on. the application thinks is the user trying to perform that transaction, and lets the transaction happen. That's, in a nutshell, is what XSRF is. The Yahoo mobile example, a month ago, I noticed that when I was logged into the full-fledged Yahoo application, and then I pointed my browser to wap.oa.yahoo.com, it showed me this application, which is really a skinned-down version of Yahoo services to fit on your smartphones or your PDA or your cell phones. And the interesting thing was, if you're logged on to the full-fledged version and you point your browser to this application, you're automatically logged in. They shared the same session cookie, session ID. And then I noticed there were two XSRF attack vectors in the IM and the calendar that were vulnerable to XSRF. So if you have a malicious code like this in your malicious site, anybody who visits your site will be kicked out of a Yahoo session. If you have an invisible iframe with code like this, your malicious site will be able to add arbitrary entries on the Yahoo user's calendar. So let's look at an example. Here you have the victim logged into the IM session and the calendar. Now he or she is going to go to a malicious site, and the victim is immediately kicked out of the IM session, so that's XSRF number 1. And then when the victim goes back to calendar, he or she will realize that there are arbitrary calendar events that they didn't add, but was added by the malicious site. The interesting thing is, when I emailed Yahoo, when I told them about it, of course they emailed me back and said thank you very much. The next day when I went to the mobile version of their site, I realized that the calendar service, they just took it offline. So that's one way to guarantee 100% security, is just to take it offline. I think if everybody in this room takes a pledge to report one vulnerability each to one of Yahoo's each applications, tomorrow when we go there, it'll be a blank page, right? Preventing XSRF, the worst thing you could do is rely on post. The calendar example we saw actually used post request to perform XSRF. Relying on the referrer header is also a pretty bad idea. There are some plugins that may allow you, a malicious user, to forge the referrer header. A good way to prevent XSRF is to use random tokens. When a user logs in, pick a really big number and assign it on the server side to that user, and expect that token to be sent to you for every get or post transaction or important transactions. Now, most of the efforts for XSRF have been done on the server side. There are people in the research community who started to ask, well, shouldn't the browser be doing something to help prevent XSRF? I think that's an interesting problem. But the problem with that is, you have things like cross-domain images. I mean, when the World Wide Web was developed, that's always been fair game. It's been annoying for people who leech off resources, but posting across domains is also fair game. But I did come across a paper and a tool called Request Radio by Martin Johns, and I think Martin is going to be talking here at 2:30. So if you're interested in a topic of client-side XSRF protection, you could come to his talk. The reason I brought up the Yahoo example, I mean, I don't think it's finding XSRF is so common, you could probably find XSRF in most applications on the internet. The reason I brought up Yahoo as an example is because I think it illustrates the concept of cross-application, cross-site request forgery. So let us understand what happened. You have the innocent user that made a GET request. The malicious site sent back an XSRF payload, right, which caused the innocent user's browser to make a transaction on the mobile section of the site, right? And as soon as that happened, the mobile section persisted the data into the database. The interesting thing here is, because of this attack, when the user actually went to the full-fledged version, the data he had in the full-fledged version was also affected, right? So the point I'm trying to bring across is that of risk today in applications. Risk is no longer at the application layer, it's at the data layer. So I'm speculating here, but just to drive my point across, I could almost speculate an executive or a business owner in Yahoo saying, well, millions of people use the full-fledged version of our application, so let's spend more money doing assessments and code reviews for that version. Let's not worry about the mobile version because not too many people use it. And I think that is flawed because the risk is at the data level. So the way it should have been done is take a look at the data you have and say, this is high-risk data. We cannot lose this data. This is our customers' data. All applications that write or read to it are also high risk. It doesn't matter how many people use it or not if they're facing the internet. That's the point I wanted to bring across. So assessing for XSRF, no tool that I know of, at least commercially, will assess for XSRF automatically. Before I left for Vienna, I did see a press release from AppScan saying that they have some beta version where they will assess for XSRF. I can't talk about that because I haven't seen it, but I'm not holding my breath. Reason for that is, take a look at these two URLs. Let's assume both of them are vulnerable to cross-site request forgery. You have one that performs something called actions equals hello, kind of seems like a hello world thing, and then the other URL that performs actions equal delete user. It is clear that for the delete user example, you don't want cross-site request forgery happening if you're the owner of this application, right? Now, if you point an application scanner with zero knowledge, the way vendors like to sell them, an application scanner is not going to be able to differentiate between these two actions, right? Same thing for code analysis. No static code analyzer has the ability to find for XSRF. How could they? I think is extremely easy. You make the analyst point out important actions, or the analyst can say, all get and post requests on my application must be protected against XSRF. Here is my anti-XSRF token, or in the case of a code review tool, here's my anti-XSRF method. If you don't see it being invoked during important operations, alert it as XSRF. So speaking about XSRF, it can be abused from an impact perspective to perform transactions on an intranet site, thereby blowing open any firewall rules you may have. So to illustrate, let's assume that there's an innocent programmer in the Google's intranet, and he performs a GET request to the malicious site. The malicious site returns back an XSRF payload, which in this case is going to make his browser connect to corp.google.com and issue the action self-destruct. And so as soon as that happens, corp.google.com will self-destruct, right? So this illustrates how XSRF can really be a bad thing for the intranet. It can actually set your machines on fire. No, I'm just kidding. When it comes to cross-site scripting, when you mix cross-site scripting, especially persistent cross-site scripting, with XSRF, an interesting scenario occurs. Of course, the probability of what I'm going to show you is admittedly slightly lower, but I think it's an academically interesting attack vector. Let's assume you have an application on your intranet running on 10.0.0.1 that is vulnerable to XSRF and persistent cross-site scripting. And you have another application on 10.0.0.2 that is vulnerable to XSRF. What can an attacker do? Let's say you have an innocent CSO who's going to be the victim this time. He connects to the malicious site. The malicious site sends back a payload that abuses XSRF and then uses XSRF to insert persistent cross-site scripting into 10.0.0.1. So what ends up happening is, from now on, anybody who connects to or browses to 10.0.0.1 from the internet will be sent back an XSRF payload and will end up performing a transaction on 10.0.0.2. So basically, you have persistent XSS can end up making XSRF persistent as well. Now that we're talking about XSRF, which is really abusing the browser to perform transactions you don't need to, let's talk about what it means as an application owner. I'm assuming you're responsible for securing an application in the company you work for. What does it mean to you when web browsers and plugins have vulnerabilities? One of the advantages you have as an application owner is when you find issues in your application, at least you can fix them, right? But when you find issues or somebody else finds issues on a web browser or a plugin, you have no control. You take the risk, it's your risk, but you have no control. So to illustrate, I'm going to talk about Flash's brain-dead cross-domain policy and the Adobe PDF plugin vulnerability that was released earlier this year, as well as the jar protocol handler vulnerability in Firefox that was released, I think, a week or two ago. The cross-domain XML. Take, for example, AJAX, XML HTTP request. You can't make an XML HTTP request across domains because that would be disaster for security, right? Let's say you have an XSRF protection on your website. Now, if I can make cross-domain requests from a malicious site, I can just fetch the content of your site, get your XSRF token, and defeat your XSRF protection. So you don't want cross-domain requests coming from malicious sites. However, in the case of API.flickr.com, for example, they expose services that are meant to be consumed by things like Flash plugins running on people's browsers. So if you know what you're doing, you can opt in and have a cross-domain.xml file in your web root. So if you go to api.flickr.com/crossdomain.xml, you'll get back a file that looks like the one in red, where the web server is saying it's okay, allow people to make cross-domain requests to me. And in cases where you know what you're doing, that's okay. But the problem with Flash is, in the recent versions of Flash, you can place a cross-domain file anywhere. It doesn't have to be api.flickr.com/crossdomain.xml. It could be api.flickr.com/xyz/123/crossdomain.xml, and Flash will accept it. The problem that creates for application developers is when you create and write applications, you're not thinking about all this. You don't know that Adobe decided that cross-domain could be anywhere. Now it's your problem. And if your application, for example, allows people to upload and download XML files, you're screwed. So now you have to start thinking about common plugins and how browser features work and make sure your application is still fine. So just merely doing a code review is not enough anymore. The Adobe's PDF plugin is just a great example. Here you are spending thousands of dollars or euros doing assessments on your applications, and then here comes along Adobe and just screws up everything for you. In this case, the vulnerability found was in Reader 7.0.8 or earlier. All you need for cross-site scripting is if your server serves a PDF. If you have a PDF anywhere that somebody can download, you're susceptible to cross-site scripting thanks to Adobe. So let's assume you have the following link, yourserver.example.com/example.pdf. Now in my malicious site, say I construct a link like this pointing to your PDF, but after that I put in the number sign or hash sign, shift3, whatever you call it, and put in JavaScript after that. What will happen is, when somebody clicks on that link, the browser will download the PDF, spawn Adobe, just show you the PDF, and then Adobe will make the browser execute the JavaScript code in context of your domain. Therefore, there's cross-site scripting. The instance where it gets worse is if you're looking at your server logs, you don't see the stuff that comes after the PDF because that's for the client to process. You only see a get, for example, .pdf. The reason why this issue is important and interesting to me is because there's nothing you or I could do as application owners to fix this besides stop serving PDF files. And people, when they install their laptops for the first time, they install Adobe. Who updates their Adobe plugins often? Similarly, the jar protocol handler vulnerability that was announced, I think, 2 weeks ago, also causes universal XSS. So if you have a URL like the following, jar:/HTTP, basically a pointer to a jar file. A jar file is really something like a zip file. And then you put an exclamation mark and actually refer to an HTML within the jar file. What will Firefox do? It will download the jar file, unzip it, take and execute the actual resource within the context of your domain. Sounds bad, but then when you think about it, it's not that bad. I mean, how many applications allow you to upload and download jar files, right? The situation where this gets really bad is, consider the case of a redirect, right? Google has a free redirect, which is bad in itself, but it makes the problem worse for Google. You have the redirect where groups.google.com/search history/URL, and then you give it any URL you want, and the Google server will redirect you to it, right? Now let's say I have a malicious server where I have the jar file with an HTML that does cross-site scripting, and somebody clicks on this link. What does Firefox do? It gets redirected, it downloads the jar file, executes the stuff in the jar file within the context of the person who redirected it. So what this basically means is Google today is suffering from universal cross-site scripting across the board until Firefox decides to fix this problem, which I think they've promised in the next release. So to wrap up, I think we in the application security community need to do a better job of understanding and presenting root causes of issues and their impacts, and the fact that data is really should be used to measure risk, not how many people use your applications. Threat modeling is a great solution in this situation, where threat modeling allows you to even tie your applications and think about where your risk really lies, and it visually sometimes illustrates that the risk really lies in the data, not in the application itself. Automated tools have their limitations, but I think they are useful too, and I think there's a lot of room for improvement with automated tools. Browser plugin vulnerabilities are important because even though as an application owner you might not be able to do anything about the risk, it's important to measure and understand what the risk is. So with that said, I think application security will continue to be the layer where we'll see the most types of attacks, and so I think there are a lot of interesting things to come. So with that, I'd open up to any questions. Cool, thank you.